We're going to do a very brief overview of statistics and statistical analysis. Very brief. Okay? So, statistics are facts and figures. They're supposed to summarize large quantities of information, make it meaningful. Well, it turns out in statistics, you need to have an idea called samples and populations. So usually when we do our research, we want to know global truths. Okay, so an IO psychologist might go into a factory and say, "Well, I wonder what would happen if workers had a stool to sit on when they're doing their work." Okay, and so what's going to happen is they're going to perhaps measure 50 workers, maybe 50 with, 25 with stools, 25 without stools, and see how it influences productivity in some way, shape, or form. But what's happening is that you will then take your sample of scores and you will use descriptive statistics to describe that sample. Okay? So you will describe those 50 people, and descriptive statistics are facts. They just are. I measured 50 and this is what I found. But usually what happens is I'm not interested in these 50 people. I'm interested in my entire factory with thousands and thousands of workers. And so what's going to happen is I'm going to take the information from the sample and make an inference about the entire population or every worker, right? And that's the second group down there, inferential statistics. So we describe samples and then use those to infer some larger population. And then we'll talk about meta-analysis tacked on at the end there. Okay? So when we describe samples of scores, there is a variety of measures that we need to establish, and we'll just talk two very briefly. One is called measures of central tendency, and that is to come up with one number that does a good job of describing all the numbers. Okay? And so there's three different ways to do this: the mode, the median, and the mean, with the mean being the most commonly used, and it being basically a mathematical average kind of thing. Okay? But in addition to describing the central tendency of a sample of scores, we need to talk about the dispersion, how spread out. Sure, I got that one central number, but how spread are the scores from there? And so there are three ways to measure dispersion: the range, the variance, and the standard deviation. And just like with the measure of central tendency, the mean is the most common. When it comes to measuring dispersion, the standard deviation is the most common. We find that in later statistics, like the analysis of variance, the ANOVA, it clearly falls back on variance, but variance and standard deviation are fundamentally the same thing. Okay? So, in addition to the basic descriptive statistics, technically correlations are descriptive statistics as well, because you're simply measuring a sample on a predictor and a criterion and describing how strongly they are related to each other. Okay? We find that correlations can range from +1 to -1. And a positive correlation means that as one value is increasing, as number of years of experience goes up, the number of units produced goes up. Okay, so that's a nice positive correlation. As one gets larger, the other gets larger. You could have a negative correlation. As the number of years of education increases, the number of errors decreases. So that would be a negative correlation. Okay, so you have positives, you have negatives. They simply indicate, with a positive, as one goes up, the other goes up. With a negative, as one goes up, the other goes down. Okay? So it's pretty straightforward. Taking correlation and moving forward with it, we do regression. And so it's not just, the correlation itself is just a description. Regression is to take it forward and make predictions about the future. So if you know that as, years of experience goes up, productivity goes up. Okay, great. So with regression, you'd predict here is a worker, they have 15 years of previous experience. What do you predict their job performance will be? Okay, so you're going to use it to make a prediction of an outcome. Here's a nice simple example. You might somehow measure manual dexterity score. How nimble are the fingers? Okay, and then you might measure. Okay, predictor on the left, criterion on the right. So you might measure manual dexterity scores and predict how many products that you're going to produce in an hour. Okay, so manual dexterity score is used to predict widgets per hour. And if you get a correlation of 0.6, that's lovely, but in order to interpret it, you have to square it. Okay, and so R squared in this case is 0.36, and so you could sort of interpret it to say, if I was to measure somebody's manual dexterity score, I can predict 36% of their performance in the factory, something like that. But what happens in IO psychology, more to the fact, is if you want to predict somebody's job performance, here in this case, widgets per hour. Where's my mouse? Anyway, there it is, widgets per hour. You want to predict it. And so you would have not just manual dexterity score, but also years of experience, an interview score, and all three of these are helping to predict widgets per hour. But as you can see, as we add more of these predictors, there's starting to be overlap between them. And so each one that you add will improve your prediction, but it is going to be less and less because of the additional overlaps. Okay. Inferential statistics, as I said, when you measure samples and infer unknown populations. So you infer the thing you don't know. Look at this. You have a new training procedure. You use you look at the training procedure on a sample of workers, find an outcome, and then infer what will happen if you give it to the entire factory. Okay? There's many kinds of inferential statistics. T-tests and ANOVAs are by far the most common, but there are tons and tons and tons. But it turns out that, inferential statistics allow us to make errors. Say, for example, here, okay? Let's say, for example, you have a new training program, and you want to know, is this new training program effective? Well, number one, over here on the left side of this diagram, either the training program is not effective or it is effective. I mean, that's just the truth of it. And we have to make a decision. We can make a decision that says the new training program is no good or it is good. And as you can see here, there's a variety of different outcomes that can occur based on these the truth of the world combined with our decision. And so it's quite an interesting, which you'll learn more about in your statistics and your research methodology class, that there are these multiple consequences that have costs, and it's quite an interesting chore to balance these different outcomes out. And then the last thing I want to talk about, after descriptive and inferential statistics, which really mesh well together, but a meta-analysis is a study and these have become real popular in IO psychology. See, any one experimental research study might have 50 participants, okay? But if, let's say, for example, you have 25 different studies that are all looking at the effects of motivational leadership styles or something like this. And so any one study, but what happens is if you take 25, 50, 100 studies and put them together, you no longer have a sample size of 50, you have a sample size of 25,000 or something. And I trust the outcome of 25,000, not the results of 50. So it's a pretty cool way to combine the results from many different studies to find the overarching results. Okay? So that's it for Unit 1. So hopefully you're going to start thinking about getting ready for your Unit 1 exam.